So today what we'll do is, so if you see here, we have discussed about the alkyl halides, but we haven't discussed about the aryl halides. So we'll see how do we prepare the aryl halides. So the preparation of the haloarenes or aryl halides. Okay. So you can do this in two ways. One is through halogenation of arenes, like how we did halogenation of alkanes or alkenes. The same way here we'll do halogenation of arenes or aromatic compounds. So that's one way. And we'll be doing through the diazonium salts. What are arenes? Okay, the carbon chain with a close. So what are arenes? It is nothing but. So arenes means it's a carbon chain with a closed structure or closed ring. You can also call them as the aromatic compounds. So one such example, you can take like a benzene ring. So you can see here, it was a closed chain. So what is the formula for benzene ring? Yeah. C6H6. So you see here, it is having 6 carbons and all the carbons are closed. So you can see here, there's a ring-like structure and alternative double bonds are present. So how many bonds are present here on this carbon? So 3 bonds are there. So it can only bind with one hydrogen. The same way with this carbon, only one hydrogen. The same way with this carbon, only one hydrogen, one hydrogen, one hydrogen, one hydrogen. So remember this is the structure. CH, double bond, CH, bond, CH, double bond, CH. This structure is very, very important to understand. How does this happen? So if you don't write down these two structures, I'll erase this. You understood? So how many carbons are there? There are 6 carbons are there and there are 6 hydrogens are there. So it is C6H6, not C6H12, which is nothing but it's an aromatic compound. You call this as the benzene. If you completed, please let me know. Done? So just let me know what is electrophile and what is nucleophile. If you know or not know. What is electrophile? What is nucleophile? Simply remember, electrophile. Electro means electrons. Phile means love. Nucleophile. Nucleo means protons or the positive charge. Phile means love. So nucleophile. So if someone loves the proton, that means if someone loves the positive charge, that means it should be the positive or it should be negative. For suppose let's take a person that loves a girl. So will you say that person is a boy or a girl? Obviously the opposite, right? The same way, if it is loving the electron, that means it should contain which charge? If it is loving the negative charge, that means in turn it contains which charge in it?
Opposite charge.
That means which charge? Positive charge. Okay. It is a positive charge. It is positive charge which loves the negative charge. So remember this one because this is very, very important. Nucleophile. Nucleophile means it is loving the positive charge. So it contains which charge?
Negative.
It contains the negative charge. So it is negative charge which loves the positive charge. So remember this, don't confuse between the electrophile and nucleophile. So remember just now itself, electrophile. Electro means a negative charge. So it is loving negative charge. So it contains in turn the positive charge. Nucleophile, it is loving the positive charge. That means it is itself a negative charge. So it is loving the opposite positive charge. Remember that way. You understood what is meaning of electrophile and nucleophile, right? Okay, so hallucination of arene. So actually this hallucination of arene It is a classical example for electrophilic substitution. Okay. So remember that it is a very, very good example for electrophilic substitution. So what is electrophil substitution means? Substitution means you are substituting something. And what you are substituting here, you are substituting electrophile. So electrophile means what? Something that loves the negative charge or the positive charge.
Negative charge.
So it will contain which charge? It should be a cation or anion.
No, it should be anion.
Die. It is a cation.
No,
If it is loving the negative charge, that means it should be a positive charge, right? How can it be an anion? Anion means negative charge. Arey yaar, you guys are so confusing. See, cation means positive, anion means negative. If electrophile is loving negative, that means it should be a cation. It should be a positive charge. So it loves the negative charge. Don't confuse that. Okay. So you can take the chlorine. Okay. All these are the examples for electrophilic substitution. So remember, hallucination of arenes will happen with a mechanism. That mechanism, we call it as the electrophilic substitution. First, suppose you see here, this is the benzene ring. So this benzene ring is attacked by an electrophile. So electrophile, it should be containing the positive charge. So which replaces this hydrogen, and here this will go and bind there. So this will go and attach to that point, and it will remove this proton. Remember, it is removing the H plus ion and it is attaching the E plus ion. So generally fluorine, chlorine, they should be negative charge, but I'll tell you how they become a positive charge. So remember right now, the electrophile, it is substituting a proton. The electrophile, it is substituting the H plus ion. When it is doing that, you will be getting the compound, a benzene, where the electrophile is attached on it. So instead of hydrogen, now you will be having this E there. E means electrophile. Okay. And you are removing this proton, so it will be left as EH plus. Okay. So just remember this reaction. There is a benzene ring. That benzene ring, when you are attacked with an electrophile, this electrophile is replacing the hydrogen on the benzene ring, and this electrophile is going and attaching there. So that is turning out to be like this. Or you simply put E plus H plus. Understood? So what is meaning of electrophilic substitution means? Simply you are substituting the electrophile here. So remember the hallucination of arene, it mainly happens by electrophilic substituting. So what you are doing here, you are taking an halogen here. So this electrophile is nothing but a positive halogen. So halogen are generally negative, but here it's a positive halogen. That could be the chlorine or bromine. It is chlorine or bromine. Okay. So this chlorine or bromine, it is going and attaching to the carbon. It is removing the hydrogen. So that's how you are getting the H plus here. Have you understood this thing?
Yes, sir.
Okay. So let's see an example here. So electrophilic substitution reaction. So let's take a benzene ring, which are having the alternate double bond. Okay. So let's say this is CH, 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 CH. I'll be writing this as like this. Carbon that is attached to the hydrogen. Okay. So in presence of the chlorine, Cl2. So I can write this Cl2 in the form of Cl bond Cl. So what happens if I break the bond between the chlorine and chlorine? If I break this bond, what happened? The electrons present here has to shift to one chlorine. Okay. So when electrons are shifting to one chlorine, what happened? then one chlorine will become positive, the one which lost the electrons. The other chlorine which gained the electrons, it becomes the negative. Okay, so this will be turned as the Cl minus. Now I told this Cl plus as the chlorine that is going to attack this hydrogen. Okay, so this is my electrophile because it is containing the positive charge. Usually we know the chlorine should contain the negative charge, but this chlorine is containing the positive charge. So it needs to balance that charge. It has to gain the neutral charge. For that, it is going and attacking the hydrogen present on the carbon. Understood? So this will go and attack on the hydrogen. It will break the double bond here. To be honest, it actually doesn't go and break this hydrogen. It actually happens on the pi electrons. Okay. So they will break the pi electrons. So the chlorine will go and attach to the carbon. But this carbon, it is holding the chlorine as well as the hydrogen. So it cannot hold two persons at a time because carbon can have only the four bonds. But here the fifth bond is happening. So due to that reason, the carbon will remove one hydrogen. So that hydrogens will turn out to be the H plus. So right now you just remember like this. So the Cl, they are breaking the bond. So when they are breaking the bond, the electrons are moving to the one chlorine. So that chlorine is turned out to be the negative, and another chlorine is turned out to be the positive. So that we call it as an electrophile. This electrophile will attack the hydrogen and replace this hydrogen. Okay. So I don't say this will attack the hydrogen. Actually, indirectly it will do. So you can say this chlorine, whatever the electrophile is there, it is replacing this hydrogen. That's why we call this as the electrophilic substitution reaction. Okay. And this happens with the help of FeCl3. And this happens at the temperature 25 degrees Celsius and form a product. That product is nothing but the benzene ring attached to this chlorine. So whatever this chlorine is there, it went and bind to this carbon. It replaced this hydrogen. So you will be replacing this hydrogen. So remember this. You are breaking the bond between this carbon and hydrogen, and you are replaced by this positive chlorine. Okay. So that's how you have the chlorine here, which is attached to the benzene ring. Plus, whatever this Cl, whatever this H plus is leaving here, that will bind to this Cl minus. You are getting what here? You are getting an H plus here. And you have a Cl minus here. So this Cl minus, this H plus, they will join together and it will give the HCl. Okay. Understood? So we are using the FeCl3 in this reaction. That FeCl3 is nothing but the Lewis acid mechanism. I'll tell you in detail what happens exactly. Just now, you just simply remember this electrophilic substitution reaction means this much you need to remember. If you want the entire mechanism, I'll give you the entire mechanism as well. How actually things will happen. Okay. So remember the chlorine or bromine we will use here. Okay. In presence of this Lewis acid, it could be the iron chloride or it could be the aluminum chloride. Okay. That will react with this benzene and that will remove this hydrogen and replace with this electrophile. So it is turned out to be the alloarene. You can see here, this is an halogen group. Sorry, this is an arene group which is attached to the halogen group. So alloarene will be formed. So this is arene, this is halogen. Understood? Is that clear?
Yes, sir.
So just remember this. You can use the chlorine and bromine in presence of this Lewis acid, which is AlCl3, or you can also use the iron chloride, FeCl3. Okay. So what they will do, they react with the benzene group. Okay. They react with benzene and replace the hydrogen or proton. You can take the proton means hydrogen here. So replace this hydrogen with an electrophile. So this reaction is said to be the electrophilic substitution reaction. Understood? So I'll simply repeat this again. So remember the benzene ring is there. The benzene ring having the carbon, six carbons and six hydrogens. So what we are doing here, we are breaking the bond between the chlorine and chlorine. So when we are breaking the bond between the chlorine and chlorine, we are donating one electrons to one chlorine. So when we are putting the electrons to one chlorine, it is turned out to be a negative chlorine. And the other chlorine, it is turned out to be a positive chlorine. So this positive chlorine, we call it as an electrophile because it loves the positive, it loves the negative charge. So this chlorine will go and attack the carbon and replace this hydrogen. So as we are replacing this hydrogen is removed as the positive charge and the positive chlorine will come and bind here. So that's how you are getting an alloarene here. And whatever the positive hydrogen is there, it will react with the negative chlorine and it turns out to be the hydrogen chloride. And this happens in presence of a Lewis acid at the 25 degrees Celsius. So this entire reaction is said to be the electrophilic substitution reaction. Understood? Any doubts? Do you want in detail mechanism how this happens? Okay, let me tell you. So the mechanism of hallucination of arenes. So actually this Lewis acid is useful. So actually this reaction happens in the three steps. So let's see the step number one. So what happens with the step number one? 1 second, guys. Okay. So what happens exactly in the step number one is first we'll try to form the electrophile. So formation of electrophile. So what is this formation of the electrophile? What is electrophile? It should be a positive charge or negative charge. Electrophile is a positive charge. It is a cation or anion?
Cation.
It is a cation. That means it should contain the positive charge. So what are the electrophiles here? It is the chlorine or the bromine. So you are forming the Cl plus or the Br plus. So for forming the chlorine, we call it as the chlorination, or the forming of the bromine, we call it as the bromination. Okay. So this happens like this: chlorination or bromination. So bromination means you are forming the Br plus, chlorination means you are forming the Cl plus. That exactly happens like this. The Cl2 will react with the iron chloride, FeCl3. Actually, this is called as the ferric chloride. So remember this. This is called as the ferric chloride. So when this chlorine reacts with this ferric chloride, it will turn out to be Cl plus and FeCl4 negative. Okay. So one will be turned out to be the positive charge. And as I said, Cl plus, the other will be turned out to be the negative charge. This negative charge will bind to FeCl3. So the breaking of the bond between the chlorine is happening because of this Lewis acid, FeCl3. If you don't have this FeCl3, the breaking the bond between the chlorine and chlorine is not possible. So that's why you need a ferric chloride, you need a Lewis acid. Okay. So understood. What is meaning of chlorination? That means you are taking the chlorine and you are using it as like an hallucinating agent. Okay. What is meaning of hallucinating agent? That means you are adding this halogen group to the benzene. So that's why we called it as the hallucinating agent. Okay. And how you are doing this? This is done by the iron chloride. So the ferric chloride here acts like a catalyst. So what it will do? It will break the bond between the chlorine and chlorine, and it will turn out to be Cl plus and FeCl4 minus. So that's how you are getting a electrophile here. As you are getting the electrophile here, that reaction is said to be the formation of electrophile. The same happens with the bromine as well. So what happens with the bromine? So you are having the Br2 and you are reacting with the iron bromide. Okay. And this is called as the ferric bromide. And this happens to break the bond between the bromine and bromine. So you are getting the electrophile here. So the same reaction. So here you got electrophile. So this electrophile formation is the step one. Understood? So what is the step one? And remember, you can use FeBr2 or you can also use the AlBr3 as well. AlCl3 as well. Okay. You can use anything AlCl3 or AlBr3 instead of FeBr2 and FeCl3. And AlCl3, it is said to be the aluminum chloride. Okay. So we are using this Lewis acid. So this is said to be the Lewis acid in order to break the bond between the chlorine and chlorine or bromine and bromine and making a chlorine electrophile or bromine electrophile. Once you've done that, next one, the step two is electrophilic attack.
So can you go to the previous slide once?
Yeah.
Answer.
Done? Okay.
Yeah.
So next one, the step two, it is somewhat a complicated one. So we call this one as the electrophilic attack. So where this electrophilic is attacking? So this is said to be the electrophilic attack on the aromatic ring. So what happens here is you take a benzene ring. So we know the benzene ring contains CH, 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 CH. And there are alternative double bonds are present here. Okay. So let's say double bond here, double bond here, double bond here. Understood? So now what happens is this chlorine, whatever the chlorine that we got here, the Cl plus, this is going and breaking this double bond here. Okay. So that result in formation of an intermediate compound. That compound looks like this. So you got the bond here, bond here. See, whatever the bond present here, it is broken. So I'm not putting double bond here. And what happened? After breaking the bond, this chlorine will bind and attach to this carbon. Why it is breaking the double bond? So that it can go and sit to the carbon. Because the carbon can have only the 4 bonds. So this is 1, this is 2, this is 3, this is 4. So already the carbon got 4. So how can the chlorine can bind to this carbon? Only if it removes this double bond. So it will remove this double bond. Now this carbon has only 3 bonds. So 1, 2, and 3. So now there is a space for this chlorine to go and bind because now the carbon can is attached only to the 3 groups or 3 bonds. So this will be going and binding to this carbon. Okay. So this stage, we call it as an intermediate stage, or you can also call this as the Arenium ion. Remember this. Okay. Because here, whatever the bond broken here, but this carbon is only having 1, 2, 3. 3 bonds, it is only having 3 bonds. So it doesn't have another bond. So that's why there is a positive charge present on this carbon where we are breaking the double bond. Okay. So This is said to be the Arenium ion. Remember this? It is called as the Arenium ion, or you can also call it as this as the sigma complex. Okay, just leave it sigma complex. You don't need to. Just remember this as Arenium ion, because after breaking the double bond here, one carbon is only having three bonds with it. So there is a one bond is not present, so it is gaining the positive charge. Okay. In order to neutralize that, we will be removing this hydrogen. If we remove this hydrogen, I can make the bond double bond again here. So that is why the carbon is trying to eliminate the hydrogen, because it cannot see the other carbon suffering here. So this carbon removes this hydrogen and make a bond between this carbon. So that's how you will be getting this one. So actually, this bond will shuffle, shuffle, shuffle like this, and resonance will happen continuously. Okay. So that I am not discussing. Just here the hydrogen is leaving. So that's why this is called as the electrophilic attack on the aromatic ring. That means the chlorine is going to attack on the aromatic ring. So whatever the double bond present here, it is breaking that double bond, and it is attaching to one of the carbon. When it attached to one of the carbon, the other carbon is only bound with three bonds, but actually the carbon should bond with four bonds. So that's why there is a positive charge. As it is containing the positive charge, what happened? This carbon will leave this hydrogen and it try to bond between this carbon. So that's how the third step will happen. So the third step is called as step 3. So what we are doing here, we are removing the hydrogen here. We are removing the proton here. We are removing it as H plus. So this step is said to be deprotonation. So whatever the double bond is having here, it will make the double bond between this carbon and carbon, and it contains only the chlorine, and it removes the hydrogen. So that's why this step is said to be the deprotonation. Understood. So how this double bond we got here, how this carbon has sacrificed the hydrogen or the proton, and how this carbon now is neutralized. It is not having anymore the positive charge on it. You understood this? So that's how you are finally forming this halogen compound here. So we call it as haloarene. Understood?
Sir,
And
are,
this turned out to be the HCl.
sir, are we supposed to remember all the steps or just is it for
Just
us?
understand. Just understand. I'm telling you to understand. That's it. You don't need to remember anything. How this reaction happens. Actually, here you have a FeCl3. No one tells you why we need FeCl3 in this reaction. Why there is a need of FeCl3? Why Lewis acid? I mean, the questions can come in objective. So that's why I'm telling you. Okay. See, some book has given this information. Maybe it's beyond your NCRT or beyond your levels right now. You don't need to study this much, but just understand it, why you are using, how this reaction is happening. So C6H5Cl plus, you can understand now what is electrophile, what actually this chlorine is doing. So why we called it as the electrophilic exchange. Now you can simply understand this. At least whatever that I said now, if you understood some 50 to 60%, that's more than enough. Okay, so the entire reaction will happen like this. So C6H5Cl FeCl4 minus, it will turn out to be C6H4Cl plus FeCl3 plus HCl. So this is the reaction. If I tell you these two are reacting and these are the products, can you understand anything? How they got into this product, or why this chlorine is attached to the benzene ring? Why there is a positive charge here? Why FeCl4 minus? How does the FeCl4 minus is formed? Actually, we have taken here FeCl3. How you got FeCl4 minus? You understood?
Yes, sir.
Srikar, The
Yes, sir.
question is for you because you asked me, sir,
Yeah.
is this needed to remember all this?
Yes, sir. Understood.
Yeah. So the next one. So this is the reaction. That's how it will form. But you need to remember one more thing. Take a benzene ring. This benzene ring is attached to some CS3 or some R group here, let's say. Okay. If it is attached to CS3, we call it as toluene. In referring with this R group, you have three positions. One is the nearest position, the intermediate position, and the farthest position. So the nearest position, do you know what the name is called as the nearest position? What is the name for this nearest position in refer with this alkyl group present on the benzene ring? It is ortho. Remember, it is the nearest position to the alkyl group. It is ortho. The intermediate position in respect to this, we call it as the meta. And the farthest position, which is almost the opposite, we call it as the para. So it's a ortho meta para. Remember like this, which is nothing but OMP. You can make some abbreviation. So O is the nearest position, meta is the middle position, para, it's the farthest position. Okay. So you can remember OMP, Om P. So let's see the reactivity of the halogens in electrophilic substitution reaction. Okay. So that depends on the electrophilicity. That means which one will be the strongest electrophile. So that order will go like this. The fluorine is the strongest electrophile. So it is the highly reactive compared to the chlorine, compared to the bromine, compared to the iodine. So from this, you can say the fluorine is highly reactive. So fluorination is highly reactive. So what is meaning of fluorination? That means you are attaching the fluorine on the benzene ring. We call it as fluorination. If you are attaching the chlorine on the benzene ring, you call it as chlorination, bromination, iodination. So fluorination is highly reactive. And on the opposite direction, you have the iodination. So the iodination reaction is very slow. So attaching the iodine to the benzene ring is very difficult. It is very slow process. It is a very slow. So remember this. Iodination is very slow, whereas on the opposite direction, fluorination, on the opposite side, you are having the fluorine, which is very reactive. Okay. Is that clear? So this is how you will be doing the ESR, electrophilic substitution reaction. So simply you are making an electrophile and that electrophile is replacing this hydrogen and substituting in that location. That's it. That is what the electrophilic substitution reaction means. So let's see the other type of preparation, which is nothing but diazotization reaction. That means the preparing haloarenes using diazonium salt. Okay. So this reaction, we call it as the diazotization reaction. It is said to be diazotization reaction. So what is this diazotization reaction? The primary aromatic amines that will react with the nitrous acid at a very low temperature, that is 273 degrees Kelvin, and you will be giving an aromatic diazonium salt. So what happens is the primary aromatic amines, they react with nitrous acid And this happens at low temperature, atmospheric temperature, which is 273 to 278 Kelvin. And what happens here? It gives to give aromatic diazonium salt. This is the diazotization reaction. Understood? What is meaning of diazotization reaction? So let's see what happens here. Let's take, so what we are using here, we are using the primary aromatic amine. And this primary aromatic amine, you are reacting with the nitrous acid, and you are doing this at very low temperature so that you are getting an aromatic diazonium salt. So let's see. Let's take a primary aromatic amine. That's the best one is aniline. So what is meaning of aniline? It's nothing but the benzene ring which is attached to the NH2. And you are treating with NaNO2 in presence of HCl. That's a 0 degree Celsius or 273 degrees Celsius. And you are turning this into benzene diazonium chloride. That's nothing but the benzene ring. And you are saying diazonium. Diazonium means two nitrogen. Azo means nitrogen. So diazo means two nitrogens. So you will be getting two nitrogens here, and there is a chlorine. Or you can say simply like this. Or you can remember like this, N2Cl. So this is called as the aniline, and this is called as the benzene diazonium chloride. Okay. So what is the primary aromatic amine? So it's nothing but the NH2 that is directly attached to the aromatic ring. So that's why it is called as the primary aromatic amine. So remember, what is meaning of primary aromatic amine? So I said here the primary aromatic amine. So what is it exactly? It's nothing but any amine group. You take amine group here. What is the amine group here? On the aniline, the NH2 is said to be the amine group. Okay. So this amine group, which is directly attached to aromatic ring. What is aromatic ring here? We are taking the example of benzene. Or and why we exactly say it as a primary? That means the nitrogen atom is connected to only one carbon atom here. Okay. So the nitrogen atom is directly connected to one atom. So we call it as the primary. If it is attached to many carbons, then you can say secondary, tertiary. But here, the nitrogen is directly attached to one carbon. So remember this. So then we said it as the primary because the nitrogen atom is directly attached to one carbon. So that's why it is said to be the primary. Okay. And this you are making in presence of nitric acid, that is NaNO2, at very low temperature. So you are doing this reaction at 0 to 5 degrees Celsius. Or you can say 273 to 278 Kelvin. So in terms of Celsius, it's 0 to 5. In terms of Kelvin, 273 to 278. Okay. Understood? So this reaction, we call it as diazotization reaction. It is called as diazotization reaction. So understood what is meaning of diazotization reaction?
Yes, sir.
Yeah. So the very important named reaction in board, I think many times the question came on this Sand-Meyer reaction. Okay. So this is very important named reaction you should know. So what is Sand-Meyer reaction is? It is a chemical reaction which is used to introduce. So what we are, so see here, this is the reaction. So you have some diazonium here. So as there are two nitrogen, this is a diazonium ion. And what we are getting here, a benzene ring with chlorine or benzene ring with bromine. So from that, what you can say, in the Sand-Meyer reaction, you are using some diazonium salt and you are converting into the aryl halide. You are converting into the halogen herring. So that's a Sand-Meyer reaction. Okay. So it's a chemical reaction used to introduce the halogen. It can be the chlorine or it can be the bromine into an aromatic ring, and you are replacing the diazonium here. You are replacing the nitrogen group here or the amino group here. So that's called as the Sand-Meyer reaction. Understood? So nothing but this continuation. So you got a benzene diazonium chloride from aniline, from the NH2 group. And this benzene diazonium chloride, now it will convert into the benzene chloride or the benzene bromide. This reaction, you call it as the Sand-Meyer reaction. So from year to year, it is called as diazotization reaction. And this entire reaction, you can call it as the Sand-Meyer reaction. Understood? So what's the diazotization reaction and what is Sand-Meyer reaction? So remember, this is used to introduce a halogen. And what are the halogens here? It could be the chlorine or the bromine. Okay. Or you can also use the iodine as well. Okay. And where you are introducing into the halogen, into the aromatic ring. Okay. So into the aromatic ring. Or you can say the arene group. And how you are introducing that, you are replacing a diazonium or you are replacing the amino group. Okay. So replacing an amino group, it could be the diazonium salt or you can say it's a NH2. Okay. This is N2Cl. Understood what is meaning of Sand-Meyer reaction? So how does this happens? So you will be taking a diazonium salt here and you are treating with a CuCl. What is the meaning of CuCl? It's a cuprous chloride or cuprous bromide. And you are getting the benzene chloride or benzene bromide. And if you see here, apart from that, you are releasing the nitrogen gas. So here the nitrogen gas is a byproduct for preparing this halide. Okay. Aryl halide. Okay. So remember that thing as well. So treatment of diazonium salt with cuprous chloride. You are using cuprous chloride in order to get the benzene chloride, or you are using the cuprous bromide in order to get the benzene bromide. To get benzene chloride or bromide. Okay, so treatment of this diazonium salt with the cuprous chloride or with the cuprous bromide in order to get this benzene chloride or benzene bromide. So this reaction, we call it as the Sand-Meyer reaction. Okay, so remember this. So this is nothing but C6H5Cl. They may give question like this. C6H5Cl means you don't think it's something. It's a benzene, benzene chloride. Or you can say C6H5Br. Okay. And remember, in this, the nitrogen gas is the byproduct. So nitrogen gas N2 is the byproduct. So remember this. N2 gas, you are getting it as the byproduct. Is that clear?
Yes, sir.
And there is a iodine. So what happens with the iodine? For iodine, you are not using the cuprous chloride or cuprous bromide. Instead, you are using the potassium iodide. Okay. So remember, the reaction goes like this. So you are taking the benzene group and you are taking the diazonium salt and you are reacting with the potassium iodide and you are getting the iodine group with nitrogen gas. Apart from that, you also get the potassium chloride. Okay. So what's happening here? The replacement of this diazonium group with iodine, and you are not doing with the cuprous iodide, but instead you are doing with potassium iodide. Okay. So remember this. So replacement of diazonium group with iodine doesn't require cuprous chloride. It needs potassium iodide. Okay. And you are getting the potassium chloride at the end. So that's it. These are the three different ways. I mean, two different ways. One is we are doing with electrophilic substitution reaction. The second method we are doing with diazonium salts, or you can say the diazotization reaction, which is nothing but the Sand-Meyer reaction. So in the Sand-Meyer reaction, you are only preparing the benzene chloride and benzene bromide. But for benzene iodide, instead of using the cuprous chloride and cuprous bromide, you are using the potassium iodide. So that much you need to remember. Clear?
Yes.
So let's see a few examples. Okay, so a compound X with molecular formula C7H8. So what is C7H8? Is that a benzene? How many carbons are present in the benzene?
6.
6 carbons, but we have a C7H8. That means you can say it is C6H12, sorry, C6H6, and there is a CS3 is present. Sorry, C6H5 with CS3.
So before also you told
That's
right,
nothing but
how is
before,
why is sir?
for suppose if I have C6H6, how can I attach here CS3? So I am removing one hydrogen and I am attaching CS3. Understood? Okay, let me take like this. For suppose you take the 6 carbons. Double bond, double bond, double bond. Okay. And now attach the hydrogen. Hydrogen, hydrogen, hydrogen. So how many carbons are there now? 6 carbons, 6 hydrogens. And where can I attach this CS3 now? Can I attach here? If I attach on this carbon, how many carbons will form now? How many bonds are formed? 1, 2, 1, 2, 3. And between the carbon and hydrogen, 4 and 5. So how can it be possible? So I need to remove one hydrogen. So there will be vacancy created. Then I can attach bond. So that's why it is not C6H6, it's a C6H5. So remember, whenever a substituent is attaching to the benzene ring, then you will not be having H6, you will be having H5. C6H5Cl is the benzene chloride. C6H5Br is the benzene bromide. And here C6H6H5CS3. Understood?
Yes.
So he says that this compound is treated with the chlorine. So let's say does anyone know what is this called? A benzene ring with CS3?
Toluene.
Yeah. It is called as the toluene. So this benzene ring with a CS3 is treated with the chlorine in presence of iron chloride. So why we are using FeCl3 and Cl? To simply get the electrophile. Yes or no? I told you that Cl2 in presence of FeCl3, what happened? This will convert into FeCl4 minus. This reaction will happen like this. So the chlorine and iron chloride will happen like this. Cl plus FeCl4 minus. In order to create this electrophile, we are using the FeCl3. Okay. So that all in presence of the iron chloride reacting with the chlorine. So to get the electrophile. And what does this electrophile will do? If it is a hydrogen, then it can replace the hydrogen. But it is not the hydrogen. It's a methyl group. It cannot replace the methyl group here. So it will go and sit on this position or this position or this position. So what is this position called? I told you there are three different positions near to R group. The near to R group, we call it as ortho. The middle position, meta. And the farthest position? What is the farthest position?
Para.
Para. Okay. So remember, you will be getting only two different products. One is attaching on the ortho position or the para position, not in the meta position. Okay. So the reason, leave it. It's a very big thing to tell the reason. But just now you remember that always in the reaction, they attach either on the ortho position or either they attach on the para position. Okay. So this is O, this is M, this is P. This is O, this is M, this is P. So here the chlorine can attach on the ortho position or it can attach on the para position. So what will be the answer? Tell me what is the answer here? Which option is correct? Come on guys, tell me which answer is correct here. Which option is having ortho and para position?
Option A.
Yeah. So see here, it's on ortho and it's on the para position. So you can write this. So whenever a toluene reacts with the chlorine molecule in presence of FeCl3, so that reaction will turn out to be like this. The benzene ring CS3 and it will form like this. Cl minus plus, sorry, this is plus FeCl4 minus. Now this chlorine will go and bind on here or it will go and bind on here. Okay. So you will be getting CS3 Cl CS3 Cl. Okay. So just remember this thing. Instead of knowing the reason, just remember. It's better to remember the chlorination occurs at ortho and para position relative to methyl group. So how we say something is ortho meta para, that's you are referring this methyl group and you are telling the nearest position is ortho, the middle position is meta, and the farthest position is para. Okay. So the chlorination will only happen on the ortho and para position. Remember that. So what about this? So what he is saying, a compound C7H8 that is undergoing the reaction and forming the product A and the product B successively. So here you take a benzene ring C6H12 again. So always remember C7H8, it is nothing but a toluene. Okay. So you take a benzene ring that is having CH3, which is called as C7H8. And you are reacting 3Cl. So you are reacting with 3Cl2 and you are eating this process. So you are getting A product as well as the B product. So what happens here is, so actually this step will go three ways. Okay. So first one is the first chlorine. Here the whatever the six chlorines are there, like ClCl, ClCl, ClCl. So there will be the first chlorine will break the bond and it will go and attach. Okay. And replace the hydrogen here. Now what happens is, as you are eating here, you are breaking the bond between the chlorine and chlorine. Remember this. So in the presence of light or heat, the chlorine will break the bond between them and they will turn out to be the chlorine radicals. Okay. So before what we need the Lewis acid. But here, instead of Lewis acid, you are supplying the heat or light energy to break the bond between the chlorine and chlorine. Before what happened, we need FeCl3 like that, so that it can turn into FeCl4 minus and Cl plus. But here, the heat energy is breaking the bond between Cl and Cl. So remember this. Note. So in presence of heat, the chlorine breaks the bond between them and convert into chlorine radicals. So what are chlorine radicals? Nothing but one will be turned into Cl plus, the other one will turn into Cl minus. Those are chlorine radicals. Now this Cl plus will attack on the hydrogen, not on the, it will go and sit on the ortho, meta or para. It will go and attack this hydrogen. So what happened here? So there is a carbon, that carbon is having three hydrogens, CH3. So it will go and attack the hydrogen and replace this hydrogen. So it will be H plus. Okay. And Cl will come and attach here. So that will turn out to be like this. So benzene ring with CH2Cl. You understood? The hydrogen is now replaced with the chlorine. And here again the bond will break and this chlorine will go and attack on the other hydrogen. So that will be turned out to be like this. CH2, CHCl2. Again, the chlorine will attack here and replace the other hydrogen. So that turns out to be CCl3. So like that, all the hydrogens are removed. So they will attack and remove. They will attack and remove the hydrogens. So you will be getting CH2Cl, CHCl2, CCl3. Understood? So the first chlorine molecule will replace one hydrogen present on the methyl group and will form the benzyl chloride. The second chlorine will go and attack the another hydrogen and form the benzene dichloride. The other chlorine will go and replace the another hydrogen and will form the benzene trichloride, or you can also call it as the trichloromethylbenzene. Okay. So remember the names as well. So it will form the benzyl chloride, and this is called as the benzyl dichloride, or you can also call this as the benzyl trichloride or trichlorobenzene. Here dichlorobenzene, chlorobenzene, dichloromethylbenzene. Understood? So this is what happens. And finally, you will be getting this product. So that product, we call it as the big A. So this is the A product. You will be finally getting. So the A product is nothing but the trichloromethylbenzene or benzyl trichloride. Now this A is undergoing reaction with the bromine and FeBr3. So what happens here? So whatever the trichlorobenzene you got, in presence of Br2 Fe Br3, So what happens here? When it reacts with Br2 FeBr3, this reaction will proceed like this. So it will turn out to be with the Br plus and FeBr4 minus. And now this will go and attack. But here it will not go and attack the chlorine. It will go and sit some position that actually it will sit on the meta position. It is not on the ortho position or para position, but it will go and sit on the meta position. So that you will be getting the reaction as CCl3, and you are getting on the meta position. So you may have question, sir, why it's not near to the CaCl3, or why it is not the farthest position? Why it is not the ortho or para position? Why it is meta position? Actually, it's a very big reason, but I'll try to tell you in short. So what happens is this CCl3, it is a very rich electron withdrawing group. Okay, that means it is a strong electronegative group. And why it is a strong electronegative group? Because of the presence of the chlorine. Okay, it's a strong electronegative group. And when we say someone is strong electronegative, when he is taking the electrons. Okay, so that's why this guy is also said to be strong electron withdrawing group. So what does this guy do is, so whatever the electrons present within the benzene ring, so where does the electrons are present? Wherever the double bonds are present, there you are having the electrons. And these electrons are circulating within the benzene ring. That happens by the resonance. You might have studied in your 11th what is resonance. The inside double bonds are continuously running circularly. So we call it as the resonance. So actually this resonance is happening because of the electrons. And this CCl3, it is trying to grab those electrons towards this group. So that's why it is called as the strong electron withdrawing group. Okay. And this one is making an inducive effect on this. Okay. It will withdraw so many electrons. So there will be electron density, and that will cause the inductive effect. And this will make less aromatic ring, or it will make less reactive. Okay, so what happens if it is a strong reactive? So that it can attach on the ortho position or para position easily, because those are the favorable locations. But it is making on the meta position because it's a very less reactive. So that's why the bromine is going and attaching on the meta position. And why the meta position is more preferred for the less reactive, that and all you don't remember. It's a very big reason. You don't need to remember all that. So just remember.
Sir,
Yes.
sir, can I leave?
Yeah, you can. It's over. Almost this is the last slide.
All right. Can I leave now and just review the last slide when you send the notes?
Yeah. I'm just writing this reason. That's it. Okay. Good night.
Thank you, sir. Bye.
Yeah, bye. So remember, the CCl3, it is a electron withdrawing group due to electronegativity. Okay. That electronegativity is caused by the chlorine atom. So electronegativity of the chlorine atom. So because of this reason, it will withdraw electron density. So this withdrawing of the electron density is happening by a special effect that we call it as inductive effect. So withdraw electron density through the inductive effect. So because of this reason, the aromatic ring becomes less reactive. So as the aromatic ring become less reactive, so it will not favorable for the electrophilic substitution. But somehow it will go and attach to the meta position. So just remember, aromatic ring become less reactive towards electrophilic substitution. Understood? So what will be the answer here? It will be on the meta position. So that's it. So the toluene reacting with the bromine in presence of FeBr3. So what happens is this. Is that clear or any doubts?